Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is maximum number of ones row. Okay, basically in this question, we have given a Boolean 2D array that contains zeros and ones only, and where each row is in sorted order. So each row is in sorted order of that row of that array, and find the row number with the maximum number of ones. So let's take this statement onto open board. This is our open board. Basically, this type of 2D array, Boolean array, which will provide us. Boolean array means zeros and ones. It contains zeros and ones, meaning where each row is in sorted order. What does that mean? So if the one is present in that row, then it will appear after zero. So it is in sorted order. Sorted order, sorted order. Okay. After that, we need to find the row with the maximum number of ones. So basically we need to return a row number that contains the maximum number of ones. So in the zeroth row, we have two ones. In the first row, 0 ones. In the second row, 4 ones. Okay, 4 ones. In the third row, 3 ones. So basically this row contains maximum number of ones. So we are returning the row number here. Okay. So this is the question, and solving and finding the row number is not a very difficult task. This is a very simple question. The brute force method that we can use here, it will cost us the time complexity of big O of n into m, that is nested loop. When we are using the nested loop over this array, finding the row number which contains the maximum number of ones, then it will cost us the O of n into m time complexity. So because this array is in sorted order, so we can use here the binary search. So if we are using the binary search, then it will cost us the O of n into log n time complexity. So it is a better time complexity than this. So how to use the binary search here? How to use binary search for this question? How to find the uh, row number which contains maximum number of ones? So for the count of ones in each row, we are initializing the first index of ones. In the zeroth row, we have the one is at third index. In the zeroth row, we have one at the third row, and we need to calculate the count of that ones that are present in the zeroth row. So how we can find that? If we are talking about the count value, that means this is a matrix. This is a matrix. So if you want the 4 from this, if we want the row number, that means if we are talking about the matrix dot size, it will give us the row number, that is 4. And if we are talking about the column number, is matrix of 0 dot size, if we are talking of this, then it will give us 5. That is this point is at this point, at that point, somewhere at this point. Okay, somewhere at this point. If we are using this value as a for calculating the number of ones in each row, then we can get easily the count of ones. How? Then using this 5 as this 5 minus first index of 1, that is 3, and it will give us 2. And in the first row, in the zeroth row, we have 2 number of ones, and it will give us the 2 number of ones. Now in the first row, let's talk about the first row. This is the zeroth row, and this is the first row. In the first row, the first index of 1, there is no one. Okay, no one is not present in the first row. So we can say how to find the count for this row. How to find the count for this row, and we need the count as a 0. How to find that? So basically we are saying that we got the first index of 1 at this point. That means fifth index. Fifth index, there is no fifth index is present in this array, but we can say that we got the first one. We got the 1 at the fifth index. So we are saying that we got the 1 at the fifth index, and we are calculating the count as this matrix of O dot size, matrix of 0 dot size, that is 5, minus this first index of 1. We are calculating count in the zeroth row as well. Same matrix of 0 dot size, that means 5 minus first index of 1. Here is also 5 minus 5, that gives us 0. Now after that, let's calculate the count for second row also as well. So the first index of 1, that we got the 1 at the first index of the column. So we got the 1 as the first index of column. Now we are calculating the count at this point. Matrix of 0 dot size, that means 5 minus first index of 1. 5 minus 1, we got 4. So we have the count, and this index, this second row contains 4 number of ones. So basically this type of approach we are using for solving this question. So if you got any idea how to code, what's the code of this question, so let's try. Do you do the code by yourself first? Let's try to submit that code. Now I'm starting with the solution, how to solve this question. I'm starting with the code. Now let's full screen it first. For finding the count in each row, we are using binary search. So binary search for the we have the faith in the binary search, and that binary search function gives us the count of ones. So we are providing the row number for that. Let's try code first. I is at 0, I is less than matrix dot size. It will provide the row numbers, row by row by row, 0, 1, 2, and 3. Okay. I plus plus, and we have a faith in the binary search that it will it, we are pass the binary search as a matrix and the row number in each row. Binary search gives us yes, it is gives us the count of ones in in that in ith row. In ith row, it will give us the count of ones in ith row. Okay, this function this function returns us the count of ones in ith row. Okay, now after returning, after if we have the count of that, then we need to check this as well. So we are initializing the overall max as a 0, and row number as well. Row number is at 0 as well. So let's rename it first. This is r. Okay, this is r, and this is the row number. For your better understanding, we are updating this. Okay, just give a second. Row number, and this is also row. So we are passing the 0th row for the first time, not the ith row. So count of ones in row. Okay, we are passing the 0th row for the first time. It will gives us back how much number of ones are present in that 0th row. Now we are checking that is that 0th row, that means count of in that row is greater than overall max. Overall max means we are initializing our count of ones. So let's say that count of ones, so it contains count of 1. Initially it is at 0, so we are checking that is count of ones in that row, in the particular row, is it greater than the count of 1. If it is greater than the count of 1, then we are initializing our count of 1 as a count of ones in that row, in that particular, and we are updating our r as a row index. So in this row we got the maximum number of count. If this function beats this variable, then we have the maximum number of count here, and we have that row as well, and return the r from here, returning r from here. Now let's make the binary search function here. So int, it will gives us the count of ones in each row. Okay, binary search, we are passing the matrix here and row as well. So let's copy this of vector int, so matrix and the row. We are passing row from the previous function. So apply the binary search over this. So we are initializing low as at 0 and high is at matrix of 0, matrix of 0 dot size minus 1. So we are initializing the high at that point. Okay. Now we are also initializing the first index of 1 as well. That is matrix of 0 dot size. Why we are initializing this as a matrix of 0 dot size? We are already discussed that, but again, for the calculating, if the 1 is not present and in any row, then we need the count as 0. So we are initializing the first index of 1 at the fifth index as the matrix of 0 dot size length. Okay. So we are initializing this as this. Now we are running a loop while loop, that is if low is while loop low is less than equals to high. First work is finding the mid, that is low plus high, divide by 2. So that we are checking that is matrix of row of mid contains is matrix of row of mid contains 1, is matrix of row of mid contains 1. That means we are first providing this row number to the binary search, and it will check that this is low index, this is high index. Okay, high index, and we are at this point, midpoint. Our midpoint is second index. Is this index contains 1? If it is not contains 1 there, then we need to increase our low at this point, increase our low at this point. So if it is not at here, so we can got our 1 on its right side, mid's right side. So we are initializing our low as a mid plus 1 and finding the mid again. So our mid at this point, and we got the 1. After we got the 1, then we are initializing our first index of 1 is equal to mid. Okay, let's code here for the more better clarity. We are initializing our first index of 1 as a mid. After that, we are initializing our high as a mid minus 1. Why? Let's discuss about that. Low as a mid plus 1. High mid plus 1. Because of that, at this point we didn't get 0, didn't get 1, and we are operating that else condition here. In the first condition, we are checking that is matrix of row of mid contains 1. At this point, is this point contains 1? No. So we are now in else part, and it is done. It is checking that is this area of mid of row, sorry, matrix of row of mid contains 0. If it is contains 0, in the else part it is contains 0, then we are initializing our low as a mid plus 1. We are initializing our low as a mid plus 1. That means 2 plus 1, 2 plus 1 equals to 3 at this point. Okay, now we have done the binary search of here, and we need to calculate the count of 1, that is matrix of 0 dot size minus first index of 1, and return the count, that means count of 1 from here. So this is the code. Let's try to run this code. It is work for the this test case. Let's try to submit it. So it is working for the all the test cases. Let's dry run this code. Let's dry run this code. Okay, okay. So let me erase these things first. Okay, easily, and place it at there. Let's snap the code from the IDE to the open board. So this is our code. This is our code. Checking that first okay, first okay. In this function, we have the matrix. We are initializing our count of 1 as a 0 for the first time, and row number as a 0. Okay, we are checking that we are starting a loop over the row, that is row is 0 for the first time, row is 0, and it will pass to the this condition. binary search, for the binary search. Now we are at this point, low at this point and high at this point, and we are initializing the first index of 1, first index of 1 at the fifth point. Now we are checking that is low is less than equals to high, is zeroth index is less than equals to fourth index. Yes, it is true. So we are at this point and we are finding the mid. So mid is at the second index. Now we are checking is matrix of row of mid contains 1. It is 0. So we are going to the else part and we are checking that we are updating the low value as mid plus 1. So now our low at this point. Now again we are at this point. Is low is less than equals to high? Is 3 is less than equals to 4? Yes, it is 4. True. So we are calculating the mid and it will at this point. Is, now we are checking, is matrix of row of mid contains 1? Is matrix of row is 0 and mid is at this point contains 1? Yes, it is contains 1. Then update the first index of 1 as a midpoint, that is 3 point. After that update the high as mid minus 1. Now we are updating our high at this point, high at this point, and now we are again checking is 2 is less than equals to 3. Is 2 is less than equals to 3? No, it is not true. So we are out of this loop and we are checking that, finding calculating the count of ones, that 5 minus first index of 1, that is 3, that is it gives 2, and it returns this value from this point to this point. And we are checking that is count of ones in a row, is this 2 is greater than count of 1, that means 0. Is 2 is greater than 0? Yes, it is. Then we are updating our this point as a 2 and updating our row as a 0, row as a row, that means 0. Okay, so this type of conditions are work here, and this is the dry run for the first 0th row. Let's try the second dry run for the second row. Okay, if we are talking about the second row, let's try the dry run for the second row. Now we are passing the second row here, second row we are at this row now. Okay, low is at this point, low is at this point, high is at this point. Now we are initializing our first index of 1 as 5. We are calculating the mid, so this is the midpoint. Now the second index, the midpoint. Okay, now we are checking is matrix of row of mid contains 1? Is matrix of row number of mid number contains 1? Yes, it is contains 1. So update our first index of 1 as a 2 and update the high point to the mid minus 1. So we are updating our high point at this point. Okay, now we are again checking that is 0 is greater less than equals to 1? Yes, it is. So we are again calculating the mid. So now our midpoint is here, midpoint is here. Now again we are checking is row of mid contains 1? Is 2 of 0 contains 1? No, we are going to the else part and updating our low at this point. Now we are again calculating the midpoint. Now we are again calculating the midpoint. So the midpoint at this point, the first index, and now at this position we are checking is matrix of 2 of mid, matrix of 2 comma 1 contains 1? Yes, it contains 1. So we are updating our first index of mid as a 1 and updating our high as mid minus 1. Now we are our high at there and low as this point. So we are checking is 1 is less than equals to 0? No, it is not true, and we are out of this loop and we are again calculating the column of 1, matrix of size minus first index of 1, that gives us 4 value as written. Now we have the 4 value at this position. Okay, now we are checking that. Now at this point we have at this point we have two number of ones. So it contains two numbers, it contains two numbers in this variable. Okay, it contains two numbers in this variable. Now we have the 4 value. Is 4 is greater than 2? Yes, is 4 is greater than 2? Yes, it is. So we are updating our column of 1, that is 2, as a 4 and updating our row number. First row number is 0. Now we are updating our row number as a 2 and we are returning R from here. Okay, so this is the dry run of this code. I hope you understand the question and the solution of this question. Thank you for watching.